Hello and welcome to Regulatory Solutions. This video is going to talk about our new mapping features and also describe in detail how we go about doing the analysis for your BDC fabric. So how we actually look at each point and do that analysis. So let's just get started. So logging into the software, of course, you'll come up to our dashboard. To get to the main map, you'll come over here to the map on the left side and just click map and then main map. At some point, we may add some other mapping features here, so some different maps. For now, it's just the one main map. So if you have wireless sites, it should zoom in to your sites. If not, just zoom into your location. We will talk about some of the other things like the polygons, like for your fiber or cable or whatever wireline service you might have if you have polygons on that. We'll get into that in a little bit of detail here in a minute. But suffice it to say, for now, we're looking at wireless sites. And so it should be showing your tower locations on the map when you first come in. Now we have a layer control over here, and there's lots of different layers and things you can see here. So we'll just go through some of those first. We have our base map, so we have our roads, and we have kind of this grayscale roads as our default base map. You can actually turn that off and kind of get the colored version. We like working with the grayscale ourselves because it provides better contrast for some of the other layers. So it's easier to see some of the other layers, especially when you overlay clutter and things like that. That background color can interfere with that a little bit because that is a translucent layer. The clutter is, and so we just want to make sure that you're seeing the accurate colors. So the grayscale map is our preference. We also have an aerial or hybrid map, and of course that's just your kind of your standard aerial hybrid. And then we have a terrain map, which you can see, and this just shows you your terrain topographically on the map. And we also have a clutter layer, and what this shows is your default 10-meter clutter. This is the values that we use to actually do the analysis. So this is showing the same clutter that we would see on the back end when we're actually opening the binary files and looking at those for your analysis. So there's a couple of interesting features here that you can use. So for instance, the map layers get added on top of each other as you turn them on and off. But like I said before, like the clutter layer is a translucent layer. But if you had an aerial hybrid layer and then you overlay the clutter on top of it, the neat thing is that you can now zoom in and you can actually see through the clutter layer to see where things actually are. So you can see the green here on top of all these trees on the aerial or hybrid layer. You can see roads. So, and this is something we'll caution you about here in a little bit with roads, but they are come in as this built up layer, so you can actually see how that happens there on the roads. And then things like crops and grasslands. So pink, I think, is crops. We'll look at our legend here. And we do have this legend here. Yeah, so pink is the crops, grassland is this yellow. There's some shrubland around here too. So you get the idea that the clutter overlays, and you can see that underneath by having that satellite layer underneath. Now, if I were to turn these on in the reverse order, if I turned on my clutter first and then I turned on my hybrid, the hybrid overlays the clutter, and it's a solid layer, so you can't see through it. So you need to make sure you turn them on in the right order. If something's not laying on top, just turn it on, turn it back on. Sorry, turn it off, turn it back on, and it should put it on the top layer. So that's just one of the neat little features there. We're going to go ahead and get rid of this so we can see what we're looking at on the map a little bit better. We also have, you can turn your sites on and off if you really don't want to see them. We have our AP layers. So we have our active APs. And what this represents is this is just kind of what we call our uniform or standard shape for the APs, or standard radius, I guess, for the APs. And then each AP is colored by its frequency. And right now, these colors are determined on a random basis. So when we open the map, we go and we look at all your frequencies on all your APs, and we find which ones are unique, and then we create a random color map for that. So the same APs, or this APs with the same frequency will have the same color. So for instance, this one is 2412 and this one's 2412, so they have the same color, but they may be different colors the next time you come into the map because again, it's a random generation. So, but we're showing all the APs at a standard or uniform distance or radius here, just so it's not so cluttered on the map. And we also have another layer which will show the radius that you entered for them, the coverage radius. Obviously, this gets pretty busy on the map, and it, you see lots of overlapping APs here. Now, one thing this could be useful for, and we're going to add this later, is being able to see where you might be hurting yourself frequency wise by overlapping the same frequencies in different places. And we'll be able to, down the road, turn these on frequency by frequency. But that's a feature for later. Right now, this does get a little busy, so we recommend, if you want to see where your APs are and where they point, just go ahead and use this standard active APs layer. We also have a CN heat layer. So if you're using CN heat and you've imported your polygons for that, we can turn that on and off. And we also have the network layers down here. So we have our wireless bounds. So what this is basically taking that kind of that radial AP layer and combining all of that together to create basically the gross extents of your network boundary or your wireless network boundary. And so this is actually used for clipping against your BDC addresses that you upload to us. So when they send you your addresses, it's actually county by county. And so you get, most of the time counties are kind of a square or rectangle. You'll get these big, rectangles full of data, but we don't really need to look at every single point in there. So what we do is we clip those against this boundary. And just to show you what that looks like, if we come down here to locations and we turn on all locations, this is going to be all the BDC locations that you have that are clipped by this coverage boundary. And these are going to load here. We do tile this layer because there's so many points. It just is a little easier on the browser memory to tile them instead of showing them as the actual points. And they do show up as the actual. If you were to click on one, it would give you information about those points. So we got to turn our boundaries off here because it's on top. But if we click on a point anywhere here, you can see it will give you the location ID and the address for that point. And then we'll get into this qualify here in just a minute. So again, those are our wireless bounds right here. And then we can also see if you have licensed and unlicensed, it will show you this difference. Right now, he doesn't have any license showing up here. So his unlicensed are the only ones. So that's all we have. If he did have unlicensed, there would be another option in this network boundaries layer control. Now, here's another interesting feature. He does actually have fiber here. And so we're going to turn this on and zoom in on that a little bit. So here's our fiber boundary. It's just one little area. And what he did is gave us the routes, and then we took those routes and basically turned those into a polygon using a buffer around that route. And so everywhere he had a route, we added a buffer. And so now we have this polygon. And then if you look at what we call our serviceable locations or our fiber locations, we've already done the analysis on this one. And basically, it's showing all the addresses in here that can be serviced. So if we turned on our all locations again, and we show all the BDC locations around here, you will see that obviously there's BDC locations within that boundary. If I turn off our fiber locations, you can see all these red dots in here. And we just did basically a spatial intersect in our database. And that's how we determined what was serviceable based on this buffer around his routes. So that's pretty easy on fiber. Same thing would happen if it was cable or DSL or any other wireline service. You would upload your routes, your boundaries to us. You could even draw this boundary if you know where it is. You could draw that in a KML in Google Earth or something like that. Or if you use Esri or some other program, and we can take these in as either GeoJSON, a shapefile, which is the Esri file, or KML, and then we can do the analysis on that. So, and you can give us routes or boundaries on those, and we can work with those. So let's get into some of the more fun features of the map. So some of the new stuff that we've added, and we kind of hinted at this a few minutes ago. So we're going to go ahead and zoom out a little bit just so we can see a bunch of layers. And what we're going to do here is just click on one of these dots again and bring up the info window. And then we're going to hit qualify. And what the qualify does is it's going to go out and look at every AP that can possibly service this location. And that's based on the beam width and the azimuth that you put in. And so you'll notice these shapes on the map are these kind of pie shapes for the APs. And these are built using that beam width of the antenna, the azimuth, which is the direction it faces, and the radius that you have given us in your data when you upload it or when you entered it into our system. So again, this gets a little bit busy. If we look at this, does get a little bit busy because of the overlapping APs. So I'm going to go here, and you'll notice that a new layer has popped up here called qualification. And I'm going to go ahead and turn off the qualify APs. So that turns off the pie shapes, and it just leaves my qualify paths left. And those paths now also correspond to these profiles. So for every AP in the system, we now have a profile here along the on the right hand side here, showing the graphs of the profiles from each AP that could possibly service this. So, and what these profiles are showing, so we have a line of sight, which is this red line on top. Then we have our first Fresnel, which is this blue line, and then we have what we call our 60% Fresnel zone, which is this other line, this kind of magenta line in between there. And the 60% is really, if you really want to have good line of sight, you really need to not have any obstructions in that 60% Fresnel. It's really good if you don't have obstructions in the first Fresnel at all, but the 60% is really where it needs to be clear. Otherwise, it really is probably an obstructed link. So just wanted to show you that we do look at that. And that's actually something we look at in our analysis on the back end too, is if you have a clutter obstruction in that or a terrain obstruction in that 60% Fresnel zone, we're going to consider that a no-go if it's a terrain obstruction. If there's a clutter obstruction, then we just do a clutter loss on that and the path profile, and add that into the total calculation. Now, for each one of these profiles, obviously this one isn't that great because it's got clutter obstructions everywhere for every path. If we go down and look at all the paths, there's a little bit less on this one, but it's a pretty long path, I think 7.58 kilometers. So that one's probably a no-go, but we'll look at these independently. So let's just zoom in a little bit because we're going to look at some of these closer profiles. And if you click on one of these lines, these profiles, it's going to show you all the details. So this is going to give us our position, the elevation of the tower, the distance from the AP, the bearing from the AP, the bearing from the lead or the endpoint, the azimuth of your AP, the beam width of the AP, the gain, frequency, channel width. So all these things that go into doing this calculation. And then we'll show you the free space path loss here and the line losses, which we always just throw in as 2 dB. It's a good conservative number just to stick in there for some line losses. And then your clutter losses. So this is anything, if you've gone through any trees, we actually build a profile as we go along the path, and we look at basically the distance of the clutter and the category of the clutter that you're going through. And so we have a calculation that we can do to pick up how much loss there is depending on that distance in the profile. So then we can come up with your total received signal level, which is pretty terrible here at neg 123. This is obviously a no-go. And then here's the other new thing. If you have looked at our other videos or you've looked at the product at all, you'll know we have these new throughput tiers that we've added. And so we can actually say how it's going to be serviced. So we just list these for you just so you can see. If you don't remember, obviously you probably do, but we just put them here just in case. So the best we could do is for this particular customer says he can deliver 92 by 11 at neg 70. And so that's really the minimum signal we're going to need in order to service this location. So obviously 123 up here is not going to, this neg 123 is not going to meet either one of these thresholds. So this is not a serviceable location based on this profile. Now, if we look at another one, let's just see what we get. So here's another one. Signal's a little better on this one. It's neg 84, which some people might use if they're in a real lightly or light noise environment. If there's hardly any noise at all, you might still be able to get a signal at neg 84. Really depends on a lot of factors. But again, he won't install anything under neg 70, and so this again is a no-go. So obviously this site would not work. Now these are just the two closest ones. We could look at the other ones that are much further away, and we're going to see probably really terrible signals. Neg 116. Let's look at this one. Neg 230. That's really bad. We look at this one. So again, neg 91. So that one's a little better, just still not good. And neg 336, this one's really terrible. So basically, this is what we can do. And so this is how we determine if a point is serviceable. We basically do all this in the back end instead of having to obviously look at it visually and seeing what these profiles look like. We go ahead and do this analysis in the back end, and then we order these by their qualification status in the database. So now that's looking at just any random point, so any BDC location, and you can come in and do this on the map anytime you want. But we also have our serviceable locations. And so if we come in and we turn on our serviceable locations, which you just hit this serviceable locations, and this is going to show you all the locations in green dots that we determined are serviceable. So we're just going to click on one and wait for it to bring up the profiles. This one probably only has one or two. There we go. Yeah, just one. And a couple of things to note here. I'm going to turn off the layer control so we can see everything. So there's a couple APs on this tower. Obviously, there's two profiles here. So there's one called West LTE and Northeast LTE that happen to both service this guy. So the profiles overlap, but basically they're the same profile. But you'll notice that over here on the left-hand side, this window popped up, and this is showing the best AP. So this is always going to show when you have one that is qualified, that we've determined is qualified. So this gray window is always going to show you the best one that we can get. So obviously this one's pretty good. Came in at neg 64, so that meets his. He only had one tier here because he's using his LTE, and the maximum he can deliver on that is 60 by 12 at neg 90. And so this is pretty good. So he's saying that he's got neg 64. Obviously, that meets his neg 90 threshold here, and it is serviceable. So obviously, if we had more APs that were in range, you'd see the other profiles, and you'd be able to tell. Let's look at one of these because it's actually pretty close too. And let's see why it is not serviceable. So, yep, just looking at this one, it looks like we hit some clutter along the way, along the path there. And if we want to analyze that a little bit closer, let's go ahead and do that. So let's look at our clutter. So once again, we've got this clutter up here, and we can see exactly where we start to run into trouble, which is right about this point. And you'll notice that as we move along our map, it's going to show us our elevations of every single point on the map, right? Or on the profile as we move along our profile here. So it starts with the top, which is our line of sight, and then our 60% Fresnel zone. And then underneath that is our first Fresnel zone. And then we have our clutter and then our terrain elevations. And so it's pretty important to look at this if you want to see exactly what's running, the problem here, what's in the way of your signal. And so right here, we're seeing we're hitting some trees, and you'll also be able to see as you move your cursor or your mouse along this map, you'll also be able to see on the map this crosshair where you are on the map. So this is pretty cool because you can actually see where that's hitting in your profile and making sure that you've got clutter where it says you have clutter, where you have an obstruction. And so let's zoom in a little bit more so we can actually see a little bit more detail on this. So if we move our cursor along this top profile, so you can see that right here, there's a gap in these trees showing on the profile. And sure enough, right there where the crosshair is on the map, you can see that we hit some grassland there. And we start to move along. And then right about here, we're getting back into some trees again. And that shows on the profile and on the clutter. So we know this is really, really accurate. And this is really the benefit of using this 10-meter clutter. It is really, really impressive how accurate it is. And so here we hit another gap, and right, sure enough, there's another gap in the trees. And then we get to the end, and we're just buried in the trees here. And so that's really important. It's really great information. In our opinion, this is much better than doing like an area mode, prediction, because at that you're just getting kind of a general signal strength or some kind of threshold. For this polygon that you put on the map, and you really don't know exactly what's going on at any given point. You could do some other profiles and things like that. But instead of doing that and trying to look at every single pixel, I mean, who really cares what we're getting in some general location on the map? We want to know what's happening right at that address, And so the benefit of having this fabric address data and being able to do this analysis like this really tells you how you can get service and maybe what you might have to do to get service to somebody who doesn't qualify already. So you might have to put up a little bit higher pole. You might have to do something like that. So now again, let's look at our hybrid here. We'll just do this just for grins. And we'll turn our clutter layer on again. And you can really see, this is really neat because we do add some translucency to this clutter layer. And you can really see how the clutter follows exactly where these trees are on the underlying, uh, aerial image. And so you can really see how accurate this is. And it's just super impressive. I mean, this is just such great detail. Obviously, you can get a little bit better detail if you use something like LiDAR. But in general, the LiDAR calculations are using these trees and the other things that might be in your way, the clutter values as solid obstructions. So they really don't use the underlying clutter values to determine a loss. They're just saying, there's an obstruction there. It's pretty much line of sight only. And so there is still a benefit here to doing it this way, even though the terrain and clutter isn't quite as high resolution as the LiDAR. There's still some advantages here because we can actually add some loss values, and you can see, hey, am I going to be able to penetrate that last set of trees or some set of trees along the way and still get an acceptable signal for my to deliver reliable service. So those are some of the really advanced features of the map. And this is available to you all year long. So if you sign up for the BDC service and you are paying us to do that, you can come in here anytime and look at these locations and addresses and things like that. So technically you can't use them for marketing purposes, but certainly you can come in here and do some qualifications to see if you can service a specific address. Now, last thing we're going to cover here, I think we've gone over all the layers. I'm just going to go ahead and turn these things off. And so we don't have so much on the map, and turn off the aerial. And we're going to go ahead and turn off our points. So the last thing I wanted to see, actually, I'll leave the all locations on. We do have a search capability here. And for the locations, you can either search by the location ID or by an address. So let's just start typing an address. Let's do something like 101, and we'll type Main Street. There's no Main, but there is a Martin. Look at there. So we typed a couple of things there. Let's just see where this is. So if we click on this, it's going to bring us up right to this location. And again, our tiling layers have to come in, and we probably haven't loaded this tile this close for this location yet. So here it is. So right there in the center of the map, if we click on it, sure enough, it's the same address. And we could run a qualification of this if we wanted to, just to see. It does take a few seconds because, again, we are doing this live, going out and doing these 10-meter analysis. And this one probably is not going to make it, I'm guessing, because of the clutter there. But we'll just look at it anyway. And no, it's not serviceable. Neg 187 because of the clutter losses at the end there. So, but basically we have this search, and again, you can search by ID or any part of the address here. And then you can also look for your APs or towers. So if you know the names of your APs that you want to search for, so if you want to zoom in on a specific AP or a tower, you can do the same thing. You can search for those. So this just gives you the ability. Now, this won't search for any address. It does have to be a location point. And so we search all those addresses. This is not tied to, like, the Google places or Bing, Bing addresses or anything like that. This is basically just searching your location fabric addresses. And so now supposedly they're supposed to have everything. So it should be the same thing technically, but outside of your coverage area, you're not going to find your addresses. So because that's how we clip the addresses there. So that is pretty much the quick and dirty for our new map features. We will be enhancing this. Like I said, we'll be adding things like you'll be able to shade your frequencies, but pick your own colors for different frequencies that you're using. You'll be able to create some other thematic type maps and things like that. We'll probably add some demographic type analysis in here. So lots of cool things coming down the pipe for this. But we just wanted to give you an overview on the features that we have available now. So hopefully this has helped you out a little bit and given you a little more insight on how we do things. If you need to see how the rest of the product works, please go and take a look at our main overview video. We also have some new map settings, so we have a view on that, some RF settings for how we're doing this analysis, and we have a new overview video on that as well. So thanks for watching.